Hi, hello, welcome back to my YouTube channel. I am Meghana Vaise from Sri Venkateshwara College of Engineering, Bengaluru, from the Department of Basic Science, CSA branch. Now I am going to discussing about the subject is chemistry for CSA stream. In this subject, the subtopic is corrosion. Now, first I am giving introduction about the corrosion. Corrosion is a process of reaction between metallic surface and its environment. It is an oxidation process. It causes loss of metal and hence disintegration of a metal by its surrounding chemicals through a chemical reaction on the surface of the metal is called corrosion. Example: formation of rust on the surface of iron, formation of green film on the surface of copper. The responsible factors for the corrosion of a metal by the environmental, chemicals, temperature, and the design. Different theories of corrosion. There are two theories of corrosions are there: dry or chemical corrosion theory, wet or galvanic or electrochemical theory. Dry corrosion theory. According to this theory, corrosion on the surface of a metal is due to direct reaction of atmospheric gases like oxygen, halogens, oxides of sulfur, oxides of nitrogen, hydrogen sulfide, and fumes of chemicals with metal. Depends on chemical affinity of the metal towards reactive gas. There are main three reasons of dry corrosion: oxidation corrosion, corrosion by the other gases, liquid metal corrosion. Wet corrosion theory. It is a common type of corrosion of a metal in aqueous corrosive environment. This type of corrosion occurs when the metal comes in contact with a conducting liquid. According to this theory, there is the formation of a galvanic cell on the surface of the metals. Some parts of the metal surface acts as an anode and rest acts as a cathode. The chemical in the environment acts as an electrolyte. Oxidation of anodic part takes place and it results in corrosion at anode, while reduction takes place at the cathode. Gain of electron is reduction. Differences between the dry corrosion and the wet corrosion. In the dry corrosion, it occurs in the absence of moisture. In the wet corrosion, it occurs in the presence of conducting medium. In the dry corrosion, it involves direct attack of chemicals on the metal surface. In the wet corrosion, it involves formation of electrochemical cells. In the dry corrosion, the process is slow. In the wet corrosion, it is a rapid process, and corrosion products are produced at the site of corrosion in the dry corrosion, and the corrosion occurs at anode but rust is deposited at the cathode in the wet corrosion. The process of corrosion is uniform in the dry corrosion, and in the wet corrosion it depends on the size of the anodic part of the metal. Factors influencing rate of corrosion. The nature and extent of corrosion depend on the metal and the environment. Nature of the metal, environment, temperature, motion. Types of corrosion. There are basically 8 types of corrosions are there: uniform corrosion, pitting corrosion, intergranular corrosion, stress corrosion, crevice corrosion, galvanic corrosion, erosion. Uniform corrosion. This type of corrosion results in a uniform and continuous decrease in thickness over the entire surface area of the metal. The rate of uniform corrosion can be easily determined by the measuring the mass loss or the quantity of the released hydrogen. Pitting corrosion. When there is a break in protective oxidative layer impurities. This localized form of corrosion is characterized by the formation of irregularly shaped cavities on the surface of the metal. Their diameter and depth depend on the several parameters related to the metal, the medium, and service conditions. It is non-uniform corrosion. The intensity and the rate of pitting corrosion cannot be assessed by released hydrogen. Pitting corrosion can be assessed using three criteria: the density, and that is the number of pits per unit area, the rate of deepening, and the probability of pitting. It is caused by chloride containing ion. Intergranular corrosion. Boundaries in metal alloy. Boundaries cannot material which shows electrode potential more than other. Impoverished is anodic with respect to other. Steel can be stabilized by titanium. Stress corrosion. This type of corrosion results from the combined action of a mechanical stress and thermal unequal rate of cooling for different parts. Stress induced by bolts. Crevice corrosion. Crevice corrosion is a localized corrosion in recesses. Overlapping zones for riveting, bolting, or welding zones under joints and under various deposits. These zones also called crevices. Metals with more concentration of oxygen become anode. This type of corrosion is also known as deposit attack. Galvanic corrosion. When two dissimilar metals with large difference in electrochemical potential are in direct contact in a conducting liquid, one of the two may corrode. This is called galvanic corrosion. The other metal will not corrode, it may even be protected in this way. Protective oxy layer reduce corrosion. Erosion. Corrosion because of attrition or abrasion of fluid on metal. Corrosion by erosion occurs in moving media. This rate of corrosion is related to the flow speed of the fluid. It leads to local thinning of the metal, which results in scratches which are always oriented in the same direction of the flow direction. Insulation can reduce corrosion. Prevention of corrosion. Material selection, proper fabrication or designing, alteration of environment, cathodic or anodic protection, and surface coating. Material selection. Electrochemical potential, strength, thermal expansion coefficient. Next, designing. Joints, crevices, drainage, maintenance. And alteration of environment. Reduce temperature, moisture, turbulence. And the cathodic or anodic protection. Cathodic protection. This is method of reducing or preventing corrosion of a metal by making it a cathode in the electrolytic cell. This can be achieved by means of an externally impressed current or sacrificial anode. An electrolyte is needed to ensure the passage of current through the part to be protected. This is effective only in soils or aqueous media where part to be protected is immersed. It is not effective in the atmosphere. Impressed current method. It is an external DC power supply is connected to the metal to be protected. Impressed EMF means current which is greater than corrosion current is applied. The negative terminal of the power supply is connected to the part to be protected and the positive to an auxiliary or inert anode. For example, graphite, steel, scrap, and the graphite are suitably for ground bed buried. Applications. Pipelines, underground cables of aluminium, storage tanks, heat exchangers, steel gates exposed to seawater, hulls of ships and highways and bridges. Sacrificial anode. And this metal, which has more negative electrode potential than the structure to be protected, is connected electrically to the part or structure to be protected. The structure is protected at the sacrifice of the another metal. Magnesium alloys, zinc, aluminium 5% are widely used, and these anodes are replaced as soon as consumed. Applications are underwater parts of ships, ship hull, and underground pipes, steel water tanks, water heaters, condenser tubes, oil cargo ballast tanks. Galvanized sheet is sacrificial protection of steel. With sacrificial anodes, the protected metals acts as the cathode, while a more reactive metal is attacked to the protected metal as the anode. The redox reactions will occur spontaneously while the oxidation reaction takes place at the anode consuming. Thus, the protection of the metal will have been achieved by successfully shifting its corrosion to the anode. The materials used for the anodes are either pure highly reactive metals like magnesium and zinc. Anodic protection. Metal to be protected is matte anode, and these cause formation of a protective film on metals by current. An external current is initially applied on the metal so as to passivate it. Then the current density is reduced to at the value to ensure that the passive film does not dissolve. This is passivating current. Passivating current is minimum protective current for the passivation. In presence of steel, titanium become passive. A potentiostat is used to maintain the metal at a constant potential with respect to a reference electrode. The primary advantage is its applicability in extreme corrosive environments with low current requirements. Thank you for watching.